Hey guys, Mr. G here. Now that we have graphed many sine and cosine functions, we're finally going to take a look at a graph for tangent. All right, so in this video, we're going to graph y equals to tan of x. Now there's a specific reason why I wanted to save this specific topic later on. All right, now before we get to graphing this, I definitely want to go back to the unit circle and just quickly review how to evaluate tangents of an angle. All right, so over here highlighted, we have tangents of theta. All right, so whenever we're evaluating tangents of an angle measurements, what we can do is we can take the y coordinate and divide it by the x coordinate of the angle measurement, which can also be written as sine of theta over cosine of theta. All right. Now, when graphing, we're only going to be using a certain kind of degrees. We're not going to use all of them. All right. We're going to just hand pick some that are easy to plot. All right. So let's go ahead and get started with graphing tan of x. All right. So let's say I wanted to start at 0 degrees. Okay. So if I were to evaluate tangent of 0, all I need to do is I just take 0 and divide it by 1, and I'll still get 0. So that means that tangent of 0 is going to be 0. All right. So now we're going to move on from 0, and I'm going to go to 45 degrees or pi over 4 radians. All right. Now there's a reason why I chose this as opposed to 30 and 60. Now, since we're dividing y and by the x, this over here would give us a clear answer. If I were to, since both of the x and y values are the same numbers, if I divide these two numbers, I'm going to get 1. So if I were to do tangents of 45 degrees, I get 1. So at 45 degrees, or in this case, pi over 4, I'm at positive 1. All right, so now let's move on from 45 and I'm going to go to 90. So let's say I'm evaluating tangent of 90 degrees. So what I would do is I would take 1 divided by 0. And if you do that, you get a certain kind of output. So I do 1 divided by 0, you end up with an error. So because it is not possible to divide a number by 0. So in that case, the outcome for 90 degrees would be undefined. All right, or pi over 2. All right, so let me go ahead and fill in the table. So we have 0, 0, 45, 1, then 90, undefined. So since at 90 degrees, the output is undefined, there's going to be a certain kind of line that's going to go through the 90 degrees, which is going to be an asymptote. All right, a dashed line going through 90 degrees. Okay, so I could keep going in a counterclockwise direction with the unit circle, but it seems that my graph isn't really fully completed because usually there's more than just this going on with the graph. So what I'm going to do is I'm going to look at the left side of the graph. Okay, so I'm going to start off, instead of going counterclockwise, I'm going to go in a clockwise direction. And if we take a look at the degrees that we're starting off so far, we're going from 0 to 45 and 45 to 90. So in each degree, we're going in terms of 45. If you guys recall, the quarters for this function would be 45 degrees. All right, so let's go ahead and turn to a clockwise direction at a 45 degree angle measurement. So if we turn 45 degrees counterclockwise, we're at the same spot as 315, which would be negative 45 degrees, and this will be my x and y value. All right. So what I can do is I can divide these two numbers. They're the same number except for the sign. So if I would divide these two, I would get 1. But since I'm dividing a negative by a positive, I'm going to end up with a negative 1. So at negative pi over 4, so let me write this up here. So at negative pi over 4 or 45 degrees, I'm at -1. All right? So then, let's say I'm continuing to move clockwise from 45 to -45 to -90 degrees. I'm at the same spot as 270. So with that being said, I'm at 0, -1. And if I divide the -1 by 0, the y by the x, I end up with undefined. So that means that at negative, so this should be -45. So at -90 degrees, or -pi/2, there's going to be an asymptote. All right, so I'm going to go ahead and draw a dashed line. All right. So now what I can do is I can connect the points, the 3 points that I have. So from the far left, it seems that the 2 points are going in a downward direction. And from the far right, it seems that the 2 points are going in an upward direction. All right. And I'm going to draw the arrows. So that means that in between -90 degrees to 90 degrees, we see we have this kind of graph going on. All right. It continually increases before 90 degrees, and it continually decreases after -90 degrees. All right. So if we take a look, let's see what kind of pattern is going on in this graph. So usually when we have sine and cosine graphs, we have the min, max, mid pattern going on. Now in this situation, there is no maximum, there is no minimum points. So there's going to be a certain kind of pattern that we're going to explain with this graph. So when we start with the asymptote, we're going from low point to midpoint to high point, and then we're at another asymptote. So my pattern would be, for the graph, would be low, mid, high, then stop at an asymptote. All right? So that means that for the rest of the graph, we're going to follow the same pattern. We have low, mid, high, asymptote. Low, mid, high, asymptote. All right? And remember, each degree we're going in terms of 45 degrees or pi/4 radians. So if I were to go from 90 to 135, or in this case, 3 pi/4, all right? And if I were to follow the pattern, this output would be a -1, all right? Since that's the low point. But let's double check by using the unit circle. So I'm at 135 degrees, and these are my x and y. This is my x and y coordinate. We're at -√2 over 2, √2 over 2. The numbers are similar. If I divide those two numbers, I end up with 1. But since one is a positive and one is a negative, I'm going to end up with a -1. So we were right. At 135, my output is a -1. All right, and then we'll go from 135 to 180 degrees, or in this case, pi. All right. So now with that, if I were to evaluate tan of 180 degrees, I have 0 divided by 1. Luckily, that gives me 0. So 180 degrees, 0. And then I go from 180 to 225 degrees, which in this case, that would be 5 pi/4. All right. Now, luckily over here, both of the two numbers are exactly the same thing. They're both negatives. They're both √2 over 2. So if I divide those two numbers, I end up with a +1. All right. And then I'm going to connect those 2 points. Now, we go from 225 to 270. I have 0 to -1. And if you recall, minutes ago, when we were going in a clockwise direction at -90, we were in the same spot as 270. And when we evaluated, it was undefined. So that means that at 270 degrees, or 3 pi/2, I get an undefined, which happens to be an asymptote going on. All right, so we see the pattern. We see low, high, low, mid, high, asymptote. So that means that the pattern is going to be consistent, because if we take a look at these two graphs, we see we're at low, mid, high asymptote. Low, mid, high asymptote. For every 45-degree angle measurement. For every time we're going each degree in terms of 45. So let's continue on until we get to 360. All right, so we're going from 270 to 315. I'm gonna write it up here, which in this case, that would be 7 pi over 4. And I'm gonna follow that pattern. So with that, so after the asymptote, that's when we're at low. Then from 315 to 360, I'm gonna write it down here, 360, which in this case is 2 pi. That's gonna be my mid. All right, so that 360, we reached to the mid, but I wanna continue on with the pattern. And I know that if reaching to the pattern, this would be at the high, and then this over here would be the asymptote. And recalling, each degree is going in terms of 45. So I would just add 360 to 45 degrees. I get 405. And then add 405 to 45, I get 450. All right? And then I connect the points. And we're good. So this is my graph for y equals to tangent of x. All right, we see that the pattern for the graph has a consistent pattern. All right, we go from low, mid, high asymptote, low, mid, high asymptote, low, mid, high asymptote, and it's going to continue on even after 450 degrees. All right, take care.